to high rock strengths are ideal conditions for this special machine technology to achieve high advance rates. The cutter head, with its cutting tools designed specifically for the geology, ensures an accurate excavation profile. Initial measures to secure the rock are taken directly behind the cutter head. The name gripper TBM is derived from the laterally extendable gripper shoes. Before each stroke, the machine is braced against the previously excavated tunnel wall using these laterally extendable hydraulic thrust cylinders. In the backup area, the excavated tunnel diameter is permanently supported with rock bolts and shotcrete if necessary. In addition, further supply facilities are installed. Heron Connect gripper TBMs are customized to each project, with boring diameters from 2 to over 12 meters. The machine shown here has a diameter of 8.5 meters and a length of 190 meters to the end of the backup system. With a driving power of 4,200 kilowatts, the thrust cylinders push the rotating cutter head forward. It's equipped with 58 cutting tools, the disc cutters. They are pressed against the tunnel face with a pressure of up to 32 tons per disc. Their rolling movements break single pieces, so-called chips, out of the rock. Water jets installed on the cutter head minimize dust formation and cool down the cutting tools. Optionally, integrated sensor systems ensure early wear detection. This facilitates the planning of efficient maintenance intervals for the tool change. Heron Connect offers in-house manufactured, long-lasting disc cutters, as well as customized technical support for refurbishment on site. Buckets installed at the cutter head take up the excavated material. Due to the rotation of the cutter head, the material slides to the center of the machine via integrated muck chutes. There, it falls through the funnel-shaped muck ring into the machine belt, running to the rear. Further belt conveyors or transport vehicles then remove the rock chips from the tunnel. Before each stroke, the machine is braced against the tunnel wall with the gripper shoes. The contact pressure is provided by the laterally extendable hydraulic cylinders. The thrust cylinders, fixed to the gripper unit, push the cutter head forward against the tunnel face. Several partial shields allow a flexible reaction to rock convergences. They are telescopic and stabilize the TBM during the boring process, prevent vibrations, and thus reduce wear and tear. A roof shield, often equipped with a finger shield extending backwards, protects man and machine against rockfall. The weight of the tunnel boring machine rests on the invert shield. It slips directly over the tunnel floor and serves as a pivot point for steering. After completion of a stroke, tunneling is interrupted. The machine support is extended and the gripper unit is moved forward toward the tunnel face. The gripper unit not only provides the pressure for the thrust, it also serves to steer the TBM. The view from above shows the main beam on a sliding bearing in the center of the machine. It's moved vertically and horizontally using the hydraulic cylinders of the gripper unit. The cylinders opposite each other interact on the main beam with different degrees of pressure, and thus create the fluid movement. The pivot point of precise steering is the invert shield at the base of the front shield. The current position of the TBM is permanently monitored and continuously adjusted to the specified tunnel line. In ideal situations, the gripper TBM bores through absolutely solid rock and leaves behind an accurately excavated tunnel profile. When tunneling through more fragile geological formations, the tunnel wall must be additionally stabilized. In the front shield area, the so-called L1 area, effective measures for earthly temporary rock support are possible. Roof bolt drilling rigs create radial bore holes directly behind the roof shield to install the rock bolts. Steel mesh mats can also be put into place. They're positioned directly behind the roof shield and serve as protection against rockfall. The use of steel ring beams also helps to secure the tunnel. They are pre-installed directly under the roof sheet. The complete ring is then moved to the installation position, braced against the rock, and mounted. Depending on the geology, rigid or flexible ring beams are used. The rock condition, with its geological and geotechnical characteristics, is decisive for the type and extent of rock support. In addition to the boring process, rock support is the key factor for the advanced rate of the TBM. If necessary, subsequent measures are taken for permanent rock support of the excavated tunnel diameter in the L2 area of the backup system. Additional rock bolts can be installed, and the tunnel wall lined with shotcrete. Water escaping from the rock is pumped away via a drainage system in the invert section of the machine. Cleaning of the tunnel invert is necessary so that invert segments, sleepers, or tracks can be installed directly behind the TBM. The TBM backup system and, if necessary, transport tracks travel like this. Depending on the project, there are different options for this. As an example, here you can see the feeder loader and invert elevator that discharges the material onto the backup belt. Additional Heron Connect equipment helps determine an optimal tunneling strategy and rock preparation. In hard rock, water and air-filled cavities in particular, as well as abruptly changing weak zones of the rock, are a potential source of danger. With the help of the Heron Connect Preliminary Exploration System ISP, these can be detected at an early stage. A pneumatic hammer blow on the tunnel wall sets a surface wave along the tunnel wall. At the tunnel face, it is transformed into a spaceway. When it encounters an obstacle on the rock, a response is generated via the reflected spaceway. Thus, the detection of greatly fragmented rock, water, or air-filled cavities is possible. The results of the ISP exploration can be verified by probe drilling. For this purpose, Heron Connect offers probe drilling units with a range of up to 100 meters ahead of the cutter head. Depending on the ground conditions, Heron Connect gripper TBMs can construct 1,000 meters and more of new tunnel per month. The removal of the excavated rock must keep pace with its speed. One way of connecting the tunnel boring machine and the job site above ground are efficient belt conveyor systems, manufactured and installed by our subsidiary H&E Logistic in close cooperation with the customer. This ensures precisely tailored muck removal to the needs of the TBM and the tunneling operation. Another alternative for muck removal are powerful rail-bound vehicles from our associated company MSD, or trackless multi-service vehicles from our subsidiary Technip Metal Systems. Both allow the supply of the tunnel boring machine with the sometimes extremely heavy construction materials. Heron Connect gripper TBMs are real hard rock specialists. They achieve very high advance rates in stable rock formations at low operating costs. This means extremely long drives can be carried out quickly and successfully. For example, at the Gothard Base Tunnel, 4 Heron Connect gripper TBMs coped with over 85 kilometers of tunneling, with daily best performances of up to 56 meters. Pioneering technology from Heron Connect ensures safe progress in the construction of modern underground infrastructures, exactly where they are needed.